In this video, I'd like to discuss some of the problems that you may run into when using area lights with 3D Studio Max. One of the problems that I see on forums, and I get emails a lot about this issue, is that basically the email or the problem on the forum will say that photometric lights do not work with the mental ray sun and sky or with the exposure control, and that's just simply not true. There's a couple of things to consider when you're working with an exterior scene like this and you want to add some varying intensity light sources. As you can see, what I have here, a very basic scene. There's a couple of large exterior lights, and there's a daylight system. It's probably set for something that you would see on a clear day, 2 or 3 o'clock in the afternoon. And now what I want to do is go in and add, enable these light fixtures to be on during the day. And what I'll do is just go in and add some photometric lights here. So I'll just add a free light for now. And just position this into place. I'm going to place this under, I'm not going to put it inside this light fixture. It's going to be under the light fixture. And what I'll do is make this an area light. Let's use, make this a cylindrical area light. And as you can see, there's not a real change in the actual lighting of the scene. Sure, we have some illumination here right against the glass or this light fixture, but really down here on the surface of this area, there's not a real contribution of that light source, even though these lights are really fairly intense at 1500 candela. Now the reason for that is, of course, exposure control and the time of day this is. These lights, even though they're 1500 candela, they can't compete with the energy of the sun. So what we have, the issue, I guess if you want to call it an issue, that you have here is that the exposure control is balanced for the sun and not for these particular light sources. If I decrease the exposure control to where these lights will become more visible, you can see how the daylight system is blows out the scene. It's always going to be more powerful than really these man-made lights down here. Let me just bump that back to 14. An example of this, I went and Googled some examples here for street lights, and as you can see the light source, but you can't really see any contribution that it's making to the area around here like you would see at night, obviously. Again, because this is nowhere near the intensity of the light, and the person that took this picture had to balance the camera exposure for this daylight instead of that particular light source. So if this were an evening, what I could do is come in and cut off, disable this sun and sky. I need to do so in the environment as well. And then come in and change my exposure control to something like 8 maybe, or 4. And now you can see how these are going to affect the scene. So I haven't touched, as you can see, I haven't touched the settings on the lights themselves. All that I've changed is my exposure, which is what you would do if you had a camera and were in a real world situation like this. At night you use different exposure settings than you would during the day. Now while I have this scene open, I want to talk about another issue. One is, if you notice how extremely bright this is, some of these light sources, and there you can see 154 value here. Think of this, if you see the RGB values and the real world values, as I move the mouse over to bring this dialog box up, I'm just clicking with the right mouse button to see the pixel values here. As you can see, some of these are really intense. There's 188 pixels strength, real value, I guess you could say. So what this would cause is, if you have very bright areas like this, it can create problems in your scenes with Final Gather. It may have a hard time clearing up an issue like this, because Final Gather tends to not like a very small, very bright areas of light in your scene. What this comes from is these, of course, very strong light sources here. But it can also create another problem with the anti-aliasing. As you can see, you have these jagged edges. Just because you have such a bright area, such a white area, this is so intense versus nothing. It's very difficult to anti-alias that. If you're using some of the sharper filters, such as the Mitchell or the Lancos, that effect could be even more prominent. So to make that less visible, you'd use a box filter. To make that less prominent effect, you can decrease the spread value here. I'm going to put that down to 0.25. I'm going to increase the quality, and what that's going to do is kind of tighten up that glare area. Close that and give this a render again. And so now you can see how that smooths out. That glare will actually mask over that that problem and help it alias better, because that's a post effect. So that's a kind of a trick to getting rid of those hard edges, and that would be actually kind of correct looking, maybe not that strong, but if you took a picture of something that bright, you would have kind of a glow or haze around it anyway. So that's one workaround for those sharp edges if you see that around your very bright objects. Okay, another issue that you may run into when working with area lights would be basically how the area light is emitted when using Mental Ray in 3D Studio Max. What I have here is a scene that has various photometric lights and a couple of other lights. Here I have a photometric cylinder light, a photometric sphere, photometric disc, photometric rectangle, photometric light that's set up at line as a line type. And when I say that, of course, I'm talking about the area shape here, if you will. The default point light, I have a skylight portal that's set to be a visible area light source. I have this piece of geometry that has a self-illuminated material on it that you can kind of use those as light sources if you use that with Final Gather. I'll talk a little more about that later. And then here I have a Mental Ray area spotlight, and it's set up as a rectangle light instead of a spotlight here. You can see the spotlight shape, but also the size or the shape here is set to rectangle, and it's 120 inches. So these are rather large light sources here. I believe all of these are, I'll try to keep it around the same size, 120 inches. So what I'll do is I'll give this a render and then talk about the results. Okay, now the render is complete. Here I've got a couple of the lights, as I said, set up, and some of the results are expected, and then some of the results may not be as expected, like this Mental Ray area spot, where back in the past we would all make these thinking that this was going to produce a nice even light source if we set this up for a rectangle, and as you can see, it didn't. It emits still from the center like a spotlight. So keep that in mind if you're using these standard lights like this Mental Ray spotlight here. Let me just click on this, select lights. If you're using these standard lights like this Mental Ray spot and you're thinking that just because you set up this area that it's going to emit light from that entire area, that's not the case with these. It still emits from the center. Another similar issue is with the rectangular photometric light. As you can see, it's also 120 inches long, but it's obviously brighter here than it is over here. So it too kind of emits from the center, and that tends to throw a lot of people off by, again, expecting that it will emit an even amount of light along the entire length of this light source, such as this mental ray sky portal, which I mentioned previously in the light discussion. You can use these as light sources, as area lights, and you can see that it does provide somewhat even result. It's still just slightly brighter here in the center, so I believe it's calculating from the center as well, but it's not as strong as what happens with this photometric light source. The other light sources here are fairly predictable. The point light obviously is going to emit from the center, or a point. This line is pretty evenly distributed as far as the light intensity along the length of that line. For the disk, obviously it's going to look kind of like a point. The sphere looks pretty good. The cylinder looks pretty good. If you notice this glowing object here, this piece of geometry that I have this self-illuminated material applied to, did not produce any light. The reason for that is that there's no global illumination or final gather in this scene. So you have to have final gather enabled, as well as depending on what type of glow that you're using. Here I used just a self-illuminated Arc and Design material. You can see I'm using 1500 units here, and I have it set up to illuminate the scene when final gather is enabled, which means that once I enable final gather, that object will emit light into the scene. The reason for showing you that is that these self-illuminated materials like this are not a replacement for actual light sources. As you can see, this does not emit straight direct light like you would get with a light source. This will also not emit global illumination photons or caustic photons like a regular light source. These self-illuminated materials, they can be used to provide some illumination in the scene, but generally speaking, they should probably be used to create a self-illuminated object that represents a light. For example, if I had a light fixture and I wanted to put a light bulb inside of it, I would put this self-illuminated material on the light bulb itself, and then a regular light, use a regular light source for the actual light creation. But what I'll do, I'll just go in and enable Final Gather here and give this a render. Okay, now that render is complete, you can see now that I have light emitting from this piece of geometry. However, you can also see the quality of this light versus the quality of the more traditional light sources here in this scene. To clear this up, I would have to start increasing the Final Gather settings, which naturally will increase my render times as well. So that's another drawback to trying to use self-illuminated geometry to light your scenes. Again, it's okay for secondary illumination or representation of actual light sources, visual representation of a light source, but I wouldn't recommend using it to solely light your scenes. I'd use a combination of this plus regular light sources, or just strictly regular light sources. Now, is this technically a problem that this rectangular light emits from the center? It may be. I'm not going to say that it's a technical issue, because it's not my place to say. I'm not that experienced with the calculations and everything that goes on behind the scenes with that. What I will say is that normally your light sources aren't going to be 10-foot long like this and narrow. More than likely, it won't be an issue 90% of the time. Where it will become an issue is if you're trying to create very large light sources. And I have a good example of that would be, let me just open another file here. And I'm going to open this warehouse scene, if you will. It's just basically a box, a giant beautiful box, if you will. But what I have are a bunch of photometric lights set up in here where I would assume one would normally place lights in a large warehouse like this. Now, generally speaking, the more lights that you have, especially when it comes to area lights, let me be specific with that, when you have more area lights in your scene, the render times can get kind of out of control if you're not careful. You could go in, as I mentioned in the lighting tutorial, and adjust this far attenuation and start tuning these down to bring down your render times. But what if instead of adding all of these lights, you want to just use one large light source to illuminate this room? Let's say because you want that speed increase because you're doing an animation of this scene. So instead of having to calculate all of these separate light sources, you can just put one giant light in this room and save some time on your renders. So let me just give this a render first. What I'm going to do is, while this is rendering, I'm going to go ahead and cancel this because I want to replace this concrete floor with a more neutral color so that it will be easier to see the light distribution here. Okay, so here you can see the rendered result, and we have, as you would expect, a couple of hot spots where the over or underneath where these lights are, which you would have in real life. But again, what if this was for an animated walkthrough or fly-through, and I really didn't care to see that? I just wanted a nice even illumination in the scene. Well, one would think that I could go in and delete these lights. Let me go in and switch to where I can select these lights easy. And I'll just leave one of them and bring it here to the center. And I'm just going to make this a extremely large light source. As you can see here, it's quite large. Obviously, you're not going to have a light source this large in the real world. But again, for the sake of speed, let's just say I want to try and use this to simulate a bunch of lights instead of actually having a bunch of lights. So I can tell now that what I'm going to need to do is increase the intensity on this, because when you start making area lights this large, they tend to lose their strength due to that decay, and because it's calculated from the center here. So let me just give this a render. So as you can see, as this is going through and rendering, how we definitely have a center hotspot here instead of an even light distribution along the length and width of that area light. So this really would not be an option if you were going to try to speed up your renders and just use one large area light. So unfortunately, that's a pretty big drawback of that. If you're trying to do an incorrect simulation, I guess you could call it, where you're simulating a very large light source. Those photometric lights are more geared towards real-world scales than something like this. So that can be a drawback because we don't have a nice even light source. I could use the mental ray portal light in here, like I showed in the previous scene, because it handles this a little bit better than the photometric lights, but it still produces a bit of a fall off here, and I can show you that in another scene here. Let me just open this, and here I have just a basic scene that I'll often use to test like studio setups and things like that, studio lighting. And what I've got is a mental ray portal light behind this piece of geometry, and this geometry has a translucent material applied to it. You can see the translucency weight is 0.95. It's sort of a glossy, transparent with translucency material. And what this is going to do, I set this up because I wanted that light to hit this and diffuse and sort of like a lens cover that you may see over some of these light fixtures in lighting studios, kind of like a cloth diffuser, if you will. And so I set this up. Let me go into the camera view here, and I gave this a render, and what you'll see is that it does produce a nice diffuse, but in the very center you're going to have a little hot spot here, even though this is using the mental ray portal light. And so as you can see, even though this is using that mental ray portal light, which handles that center calculation better than the photometric area light, I still have a sharp or very defined point here in the center of this material. And now there are workarounds, thankfully, to most of this stuff. And one would be for this, instead of having the light go through this material, I'd probably just put the light on the front side of the material and then make this object a self-illuminated object and give it some soft edges on that self-illumination, and that would provide my reflections, and this portal light would provide the light source. So that's kind of a workaround to this. I just want to show that if you're using a different renderer, you may not have this problem. This is something that, and again, let me just specify that this isn't technically a bug or anything like that. This is how it's just calculated. If you're using another rendering system like V-Ray, I have one set up here in V-Ray. This is just a large V-Ray light, and let me check my size here. Let me make that smaller. Let me just give this a render, and it produces a more even amount of light on its light sources than on the photometric light. So I just want to show that it's specific to those photometric lights, the way that they're calculated, it seems. And again, I'm not saying one is right and one is wrong. I'm just showing the different results that you can get if you're using different rendering systems. And this light source, an even light source like this, you could use substitute this, make a large light source in place of several different light sources if you had a nice even light distribution like this. Now there is one other area that I want to talk about that may cause some confusion, and I'm just going to go back to that studio type scene that I have. And what I'm going to do is just delete these light sources because I want to use the photometric lights instead of this. And I'm just going to add in a couple of quick objects here to go along with this, just a couple of spheres. Something like so, and just drag these into place. Like so, and then I'm just going to apply a, let me up the samples on there, or the segments, to make those smoother. And I'll just put a A&D Arc and Design material on these. Maybe have these blue. Something like so. And I want to put a light source here in the scene. I'm going to use a photometric light. I'll just put a free light in. Move it somewhere in a place like that, and I want this to be uniform diffuse because I don't need light emitting in all directions here. Roll those up. I'm going to make this a rectangular light source. Something like that. Maybe rotate it so let's switch back to my camera view. Let me just modify this camera a bit. So what I have on these objects are reflective materials. These are Arc and Design materials, and they're both reflective, non-glossy reflections, meaning they have sharp reflections. And 1500 candela may be a bit too strong here. Let me just check in the viewport and modify my exposure. In order to see how this looks, I of course need to turn on hardware shading. Okay. So one, you can see an obvious color difference here. If I pull up the exposure control settings, I have my Kelvin on the exposure control set up for whatever that was, 3200. You can see how changing this changes the look or the color of the exposure control. I'm just going to set that to 35, and if I match this with the light color here, that'll produce a white light source. And so what I want to look at here is the rendered reflections here. So to speed this up, I'm just going to go in and disable Final Gather and let this render. And so what you see here, we have reflections of this light source. But if you notice, I did not make that light source visible to the scene. You can see it's in the scene and we're getting those reflections of it, but I have not enabled this light shape visible in rendering. So if I render from this view, you can see that the light source is not visible, but yet it's showing a reflection of a light source here on the reflective objects. What that is the specular reflection of that light source. If I go in and I disable specular reflections here in the advanced effects rollout, that will remove that specular reflection of that light source from the objects here, as you can see. But now, what if instead of doing that, what if I just make this light visible in the renderer? As you can see, the light source is now visible in the renderer. However, and we do have the visual representation of this light. But if you notice, it's not a crisp reflection. It looks almost like these materials are glossy. The materials are not glossy, meaning I should have sharp reflections instead of these diffuse glossy reflections. So it's not a material issue. What's happening is it's still looking at, even though that's a visible light source, it's still looking at that specular component. If I make a copy of this, let me just put this in the RAM player, and we'll compare the result once I disable specular, but I leave that light shape visible and rendering. So we're still going to have this, but by disabling the specular, now the scene will actually reflect this visible light source instead of reflecting that specular highlight. So now you can see I get those really sharp reflections there. Let me just load this in, and you can compare the results. Let me put that there. You can see that's the specular reflection, and that's the actual reflection of the object. So that's another area that may trip you up once you're getting started and learning your way around how these lights work and some of the little nuances to this thing. So now if I wanted a glossy material, I could actually dial in the glossiness of that A&D material instead of having that fake specular. I believe one more quick note about this visible light source. If I go in and I hide all of the geometry here, I believe that's frozen. Let me unfreeze this and hide that and give that a render. Even though that light source is visible, it doesn't show up in the render. You have to have a piece of geometry. Let me undo and unhide that, and you'll see that it'll show up this time. So even though I have that enabled, if you don't have any geometry in your scene yet and you do a render, you won't see that visible light source. And that tip will conclude this video.